should have been an announcement that we're recording. Did you hear that? No. Okay, well, it says it's recording now. So the notion of a concept that I'm going to be talking about today has to do with the elements of propositional thought. We can't form a proposition without being able to put something in it. You can't say the cat is on the mat without having a concept of a cat, a concept of on, and a concept of mat. And so the whole idea of thinking really has at its foundation the idea of a concept. It's the means with which we are able to understand the world. And in particular, it's how we are able to handle our current experience through interpreting it through concepts. So if I approached by an object, I'm able to classify it as, say, a dog, and that will enable me to make predictions about the behavior of that object, how it will respond if I approach it, and so forth. Right. So just very quickly to point out how the notion of concept, the concepts that we have, are used in a whole variety of ways in our everyday cognition. Classification. So the idea here is that by calling something a newspaper or calling something an ice cream, I can refer to a whole body of information just without having to unpack it. So I can say, I need to get a bus, and I can just put in a token of bus into that thought without having to unpack all of the information about it. But if I need it, it's there, it can be retrieved just from that cue. So it's a way of very much reducing the amount of load on your working memory to be able to represent thoughts with these simple classifications, these simple tokens. In the longer term memory, to encode facts, memories, experiences, we need to have the conceptual language, I suppose it's a Fedorian language of thought, has to be there in order to put things into memory in like an encyclopedia in a way that we can then retrieve them through the cues of the words that we're using to encode. I'm not saying that we can't have non-linguistic or pre-linguistic knowledge and intelligence. It's just that it's hard to, for someone who has language to know exactly what that would feel like or how that would work. Creativity is something that I'm very keen on exploring with concepts. One of the common methods to create new ideas is to stick two concepts together and say, how would they work? And I have another talk I could give at some point about asking people to imagine impossible combinations of things. But if you think of the man who thought, how could we make a milk bottle into a cardboard box? You obviously can't, because the milk would flow out of the cardboard box. But milk bottles are hard to stack, whereas boxes are easy to stack. Anyway, the man who thought of that is now one of the richest families in Europe. They invented the Tetra Pak. And so its conceptual combination is a fascinating subject. Reference and communication, of course, fascinating study. Semantics, how we are able to retrieve meanings and convey meanings to each other. There's a lot more to it than just the concepts that we use. There's a whole implicature and so forth that you're aware of as philosophers. Every culture also has ways of understanding things. And so there are culturally specific concepts that we use to frame narratives, to explain people's behavior, to drive moral imperatives that people should behave in particular ways. And those are all also part of our conceptual repertoire. And finally, the idea of self-identity itself is a concept. So I have a concept of who I am. I probably have many concepts of who I am that may change depending on the company that I'm with. Family weekend, I'm grandpa, and I behave in a particular way, and I perceive my emotions and thoughts from the point of view of being a grandpa. Right now, I'm the professor, and I'm addressing an audience of distinguished people, so I have to adopt a different self-identity and try to be serious and maintain a coherent narrative as we go along. Hope we'll do that. So a lot of debate and ink was wasted in the early days of my career arguing about just exactly what a concept was. And coming from a rather naive Roschian prototype view, I was inclined to think, well, a prototype is just a cluster of things that you have in your mind. You've seen things, you think they're similar. You think, oh, there's one of those again. Let's put them all into a category and give it a name like furniture. Or those are all these activities that are going on. Let's put them all together if they're similar and call them sports. And with that comes the vagueness and lack of definitions that I'll be describing in a minute. But of course, the world is not that simple. And if you look at the physical and biological sciences, then you do have real concepts that you can be right or wrong about. And this idea of the principle of error, that's something that Jerry Fodor went on a great deal about, is that I can have the wrong concept. But if a concept is just defined by what's in my head, how could it be wrong? It is what it is. It's my concept. So this has been resolved now. I think that everyone accepts that, yes, there are natural kinds. There are real things out there in the world. We have, and if we're objectivists, we believe that there is a real world. And so an example like heat, before the physicists discovered the laws of thermodynamics and actually worked out the difference between heat and temperature and why things feel hot and why steam engines have limits and all the rest of it. There was a naive concept of heat, of course, before that, but it got replaced in science, in physics, by the concept of heat as it's defined here. It hasn't really entered into the language as such. GCSE students study it and quickly forget it once they pass their exam. And we just think of heat as something that makes something hot. So we've got this individual representation of the natural kind, of the real thing, at the same time as an awareness that there is a real thing there. Alongside the physical world, there is the social world. And here again, you can have the wrong concept. So there may be definitions of sex and gender that have been developed in the last decade or so, where sociological analysts and theorists and psychologists and philosophers have worked hard to try to get a clear view of exactly what the right concepts are for this. And this comes with the conceptual engineering program that Capellan and people have been promoting, that we can actually have wrong concepts applied to society. And if we can find the right concepts, we will actually do a better job of understanding society, and as Marx would say, of changing society. I guess it was Marx, it might have been Lenin. And then there's the individual, and the individual has the right to their own idiosyncratic mental representations. They perceive the world the way they do, and there's an area of philosophy on looking at when is it okay for people to each have their different views about something, and we don't have to have an argument about it. And those are the kind of concepts that an individual may possess. And these are three ways in which we end up being kept honest in terms of how we categorize and understand the world. So on the one hand, there are the natural kinds. And so children in primary school go along and they're told that actually a bat is not a kind of bird, a whale is not a kind of fish, a spider is not a kind of insect. They've forgotten that by the time they get to university. About 70% of my students think that spiders are insects. So there is this integration of the natural kind into the language, into common understanding. I think that a lot of psychologists studying concepts tend to forget that in order to become an expert user of our conceptual and language systems, you'd actually spend about 12, 15 years in school. And what are you doing there? Well, you're not just playing football and learning about history. You're actually developing the conceptual repertoire that drives your society and that leads to your ability to understand the world in a more correct way than if you hadn't had that schooling. So there is a contrast, there's a tension between the correctness of the natural kinds, the correctness of social kinds. For example, the meanings of words. You can't just go around using a word any way you like. People will correct you. Eventually they'll stop correcting you and the word will change its meaning, but that's another issue. But other things, you are able to have your own individual tastes and sensations, and you can only be honest to yourself in that case in how you describe things. So all of these concepts that I'm interested in as a psychologist, they're all in the mind, they're all in the head somewhere. And even the natural kinds are represented by these rather prototype, stereotype kinds of concepts. And I'm going to use the word prototype because I come from the tradition of Eleonora. I was actually doing my PhD about the same time that she was, and she was in Berkeley, I guess. I just finished my PhD when all her papers came out, and she had used 500 subjects and done 10 experiments, and I'd got about 30 and done 2 experiments, but I managed to get into the literature with it. That's a by the by. So this is just on the right here is a paper, one of my favorite papers by Barbara Malt, a colleague in America, who it looked at whether people thought that water was actually H2O. Why would they not? Well, what she did was to take a whole lot of different kinds of water, like bath water, swimming pool water, lemonade, Coca-Cola, mineral water, tea, coffee, and she asked people 2 questions. One, is this water? And the other was, what percentage of H2O is in there? And amazingly, perhaps, I guess, perhaps not if you think about it, there was a rather poor correlation between those 2 things. There were lots of things which people thought had a lot of H2O, but which they didn't want to call water, and lots of things that they thought didn't have much H2O, but they did want to call water. The thing that worried me was that they thought that swimming pool water was only like 90% H2O, which made me really worry about what other things they think might be in swimming pool water. But the idea is that we have to represent these things, and we use them in our loose speaking to each other, in our everyday conversations. And they are vague, they're flexible, they're handy because we're not going to catch each other out all the time trying to be accurate. So they're convenient. And they're very context dependent. As you switch from one context to another, you can adapt the concept to its new meaning. Everybody will understand. So when you think about names for natural kinds, they tend to be mostly coextensive, which is why you know it's the name for a natural kind. It can't just say that water is not H2O, but the mapping of the 2 is approximate. So I'm going to say that these are prototypes. So what are the actual phenomena in the psychological literature that makes us believe that we have these prototypes? And I'm not going to say concepts are prototypes, or you can say concepts have prototypes if you want to stick with Jerry Fodor's view of this. Well, 4 phenomena that I would point to. One is a kind of vagueness. So if you ask people whether chess is a sport, whether a tomato is a fruit, whether a painting is furniture, I've got a list of about 100 of these statements that you could use if you wanted to borrow them. What you find is that people tend to give you a yes or a no. But what Mike McCluskey and Sam Glucksberg did was to then have them back a week later and ask them the question again. And they found that actually, people changed their opinion about these borderline cases maybe 20% of the time. So they'd said that tomato was a fruit, and next week it isn't a fruit. And it's clear that this is I would relate this to the kind of vagueness that you get with is someone tall, the kind of Sorites paradox vagueness, in that it's not that there is an answer out there, it's that there is a vague region in which the truth of the statement is partial, if you like. There are many ways of treating vagueness, but any of them would apply to these kinds of statements just as they would to whether John is tall when he's of intermediate height. Typicality was one that a phenomenon that was discovered or brought out by Roche in a lot of brilliant papers. And this is the idea that even when things are in a category, some of them are more typical than others. So an apple is a more typical fruit than a banana, or a banana more than a pineapple, say. And the typicality seems to be based on some kind of similarity to an ideal or a stereotype or a prototype. The more the features of a fruit that you can share with everything else, the more likely you are to be typical. This is what Rush showed. And what I've extended from that is to say, well, the vagueness is all part of the same scheme. So I have a paper in Cognitive Science, 2007, I think, arguing that as you become less and less typical, because you've got fewer and fewer features of the prototype, so you become more and more likely to be rejected from the category. And so there's a continuum of losing features, becoming less similar. First of all, you're still in the category, but you're less typical. And then you reach a borderline region where you're even less typical, but people start to disagree. And then you fall out of the category altogether because you're so dissimilar that you can't get people to accept you as being a member of the category. The lack of classical definitions, interestingly, it was Ludwig Wittgenstein in his philosophical investigations, which seems to have been one of the triggers for Roche's research. It was also what my supervisor read that got me started on this whole issue, and you'll be familiar with his treatment of games. It's possible that you have a lot of categories where you can't sit down and say what are the rules for something to be in the category. Anything that you propose tends to find a counterexample, or it's much too broad and includes lots of things that shouldn't be there. The fourth phenomenon, genericity, is the idea that these prototypes seem to be put together with a lot of different features or properties, attributes, use those three words interchangeably. And if you say, is it true that birds fly? 100% will say, yes, it's true. You say, well, does an ostrich fly? They say, no. But is it true that birds fly? Yes. And there seems to be the fact that there are counterexamples does not undermine the truth or the acceptability of the generic. And this, some linguists have suggested that there is some kind of operator gen, which means most of, and let's not bother about the stupid counterexamples. It's useful to know this about the category, so we're going to allow it to be said, because as I was saying earlier, if you were only ever able to express universal truths, it would be a fairly silent universe around here. So the whole idea then is that you represent what is usual, general, or default. This is obviously a fundamental cognitive process, the architecture of our minds. And when you then later in the series are talking about stereotypes and stereotypical beliefs in social areas, it's the use of that fundamental cognitive architecture to apply to the human social area, domain, that is going to lead to many of the fallacious or prejudicial or other kinds of responses and behaviors that you will see. So this is just to show you some data. On the left is the data that McCloskey and Glucksberg collected, and I some years ago went through and entered it all into a computer. Along the bottom, you've got bins of typicality, starting from things which were not judged typical at all to things that were highly typical. And the vertical is just the categorization probability for those items. This is just taking the items as a whole, and these are 95% confidence intervals. You can see it falls just like a threshold for a perceptual experiment as you increase the strength of a signal, so the likelihood that it gets detected goes up. It has this nice normal curve, threshold curve, just like anything else. The raw data you can see on the right. I've just done a little correction here, but this is how you would predict on the basis of typicality that an item should be categorized, its probability, and here's the observed probability. And you can see that it follows a straight line pretty well, but there are exceptions. And a paper in 1998 tried to pull out those exceptions and see just exactly what they were. Just to example, if you look at, is a whale a fish? Hardly anyone says it is, but how typical is it a fish? People will tend to say it's quite typical. So that would be something where the predicted probability is here, but the observed probability is quite low. And you get things similarly that at the other end, if something doesn't look like what it's supposed to be, like it is a bat, a mammal, it's not a typical mammal, but people tend to categorize it as one. So the next bit is kind of out of my lecture course on psychological theories of concepts. So this is, being a keynote, I'm allowed to provide you with information that may be familiar to psychologists, but I hope you won't find it too familiar or boring. And I have interesting things I hope to say about each of these. So if you read Machery's book on concepts or Murphy's book on concepts, you'll find that the world has decided there are 4 approaches or theories of concepts. The exemplar idea is that we store individual experiences in mind, and when we have to make a prediction or a categorization about something new, we use the similarity of this new experience to retrieve exemplars of experiences we've had before, and we examine those to decide if this new thing falls into the same category as those previous ones. And that allows us to make predictions and to categorize. Prototype models is what I've been talking about so far. We notice that there are similarity clusters in the world. We use those to create categories and judge things to belong in those categories, providing they're sufficiently similar. Now notice that both of those models require you to have some way of judging similarity. You can't do an exemplar model unless you can say what is it that makes this exemplar similar to another exemplar I've seen before. So they both require something like a semantic space, like Peter Jadenfors has talked about, conceptual spaces. They're some way of judging similarity, and that is a big problem still. If you look at very simplified cases where you have just dimensional stimuli, like the flower vases that have a certain height and a certain width, then you can do lots of wonderful work with exemplar models. But if you think about sports or games, it becomes extremely difficult to work just how you calculate the similarity. Moving on, this is in a kind of scale of increasing complexity of the theories. There are theory-based schema models where you take the idea of a prototype, but you build more structure into it. And I'm going to discuss these in a little bit more detail next in the next few slides. And finally, we'll come on to essentialism. This is psychological essentialism, which is distinguished from philosophical essentialism in that we don't actually believe that things are essential, but we're studying the fact that people do. That's what makes it psychological. So let's just say a little bit about exemplars. I'm not going to talk about the classification learning work. There's a lot of been done in labs all around the place, giving people tasks where here's something, is it an A or a B? Here's another one, is it an A or B? And you go through 20, 30, 40 minutes of this until somehow you've learned what an A is and what a B is, and then you're tested to see if you generalize to other cases. It's interesting work if you like that kind of thing, but I don't think it really has anything to do with concepts that we use, the kind of concepts I'm talking about today. So I'm not going to go into that. But you do find areas in the real world where you can say that people are using exemplar knowledge. For a start, when you think about how children actually learn about real world categories, they're first of all going to be experience exemplars. How do they know what food is? Well, it's the different things that get put on the plate in front of them at tea time. How do they know what games are? Well, they're the different activities that adults encourage them to play. Animals, well, they come across animals in the street, they see animals in videos on YouTube, whatever. So we do have to experience exemplars before we can start to form categories. Sloman and Molt have an interesting thesis about artifact categories. That's what we used to call man-made objects or person-made objects. That what makes something a cup or a box or a plate actually just has a lot to do with linguistics history and how particular objects got their names. Because when you look at how people name containers, for example, it varies from language to language, and it doesn't seem that they're based on similarity particularly. There just seem to be a history of, they're just a bunch of things that happen to end up with the same name. There may be some broad functions, but that in itself is not enough to make the difference between the different categories that you have of a carton and a box and so forth. So that would be definitely an exemplar kind of learning where you just, the name of this is one of those without using similarity. A lovely study by Storms, very quickly tell you about this. They collect Gerd Storms in Leuven in Belgium. They went to the local market and bought a lot of exotic plant produce, fruits and vegetables. And they laid them out on plates in the laboratory, and they had students come in. And the task was just to say, is this a fruit or a vegetable? And they were allowed to smell it. I don't think they could bite it, but they were allowed to sort of examine it and smell it and feel it. And what they found was that the way people did that task was not by judging whether it had the features of the prototype fruit or vegetable. They were able to show very cleverly that it was because they found whatever fruit or vegetable this was most similar to, but at the level of basic levels. So if it looked and felt most like a grapefruit, then it was a fruit. Or if it looked and felt most like a turnip, then it would be a vegetable. And so it was actually at the basic level that they were doing the similarity judgments and not at the superordinate. I'll move on because I think I'm going to be running short of time at this rate. Just to say that if you go to the Natural History Museum in the archives there, they have the original specimens of different species. That the way that the biology, and at least in those days, this was before DNA sequencing, but in the 19th century, you discovered a species, you brought one home in a bottle, and that was the original species, defined that species in terms of the physical specimen, the exemplar of it. And that way you could never argue whether you did the drawings wrong, or because you could go and look at it in the bottle and say, ah, yes, this species has these features. Interesting. Prototypes, I've said a lot about already. There is extensional vagueness, membership and typicality. There is intentional genericity. And it's worth noting that both the category members, which I'm calling the extension, and the category features, the properties, which I'm calling the intentions, they both have degrees of typicality. Not only is an apple more typical as a fruit, but having seeds is a more typical feature of fruits than growing on a tree, for example. And so, like everyone else, we prototype theorists assume that the extensions come from the intentions. Theories and frames. This is just the idea that you can build more structure into your features. Instead of just saying, oh, birds are creatures that fly and live in trees and sing, and you can say, well, the reason they live in trees is to escape predators, which they're able to do because they fly. And while they're in the tree, they build a nest, and which is where they lay their eggs. So you have a structural of knowledge from which you have picked these particular individual features. And this is very important, and people like Bob Rader have done this with artificial learning materials to show that people actually take these causal links very seriously, and they drive categorization and drive typicality judgments if those correct causal links are there. Having the right features is no good if you don't have the right links. It's a bit like saying, well, the dog has to have a face and 4 feet, but it's no good if the face is underneath and the 4 feet are stuck on top. Theory of schemas I really like is Larry Barcelow's idea of mental simulation. So Larry has the idea that what a concept does for you is it allows you to simulate in your mind's eye something. So what your concept of a ladder allows you to do is to think, I've got the ladder, I'm going to put it up against the wall, better make sure that the base is far enough away and that it's stable, now I'm going to climb up. And you can construct a whole story in a fantasy world just by having the concept of ladder, and that's what the concept allows you to do, and why you can quickly understand that something like a chocolate teapot is just going to be a really hopeless thing to try to build. How did you know that? Well, you've never seen a chocolate teapot, but you immediately know because you can simulate a chocolate teapot in your mind using your concept of chocolate, using your concept of a teapot. And while we're on this, there's Rosenblit and Kyles have a wonderful study which shows that while we can assume that we do have all these wonderful structured schemas for understanding the world, we're tremendously overconfident about how much we actually understand. If you take a simple example like a toilet flush, you say, okay, what happens? Well, I push the handle. This is the old-fashioned kind of push the handle, and there's a whoosh, and the water comes out. And then when the water's finished, it fills up again. And so just actually what happens inside the tank to make that happen? And people really don't know. Though they claim to begin with that they really understand it, but when you've asked them to draw a picture and explain it, they change their ratings to say that they really didn't understand it. So this, from the point of view of a prototype theorist, is sort of putting in a bit of a dig to say, well, people have schemas, but they don't use them all that much, and they don't really know what's going on. Prototype concepts, you might think we don't find them in science. After all, science is supposed to be honest to the world, but scientists, like anybody else, have to have prototype concepts in order to be able to communicate. And they only need to make tight definitions when they actually need to put things into formulae, into equations, into theories. So in medicine, the medical terms like arthritis, it's a large number of different conditions are called arthritis, many which have very little to do with each other, except that they involve inflammation of a joint. Arthritis just means that you have an inflamed joint. So the major categories in medicine are not all driven by etiology and causes and things. They're also just driven by simple areas of symptoms. And so these are just broad prototype categories that they use as much as anyone else. And the same is true in biology. You may know about the problem with species, that biological taxonomies have been very tricky to get clear, and you can't do it if you want to have a sensible conversation about reptiles or fish, because reptiles are not a properly defined cladistic taxon, if that's the word. You probably know the example of Pluto. I like this one because it shows how scientists have to revise their ideas and actually come up with new definitions. We always used to think there were 9 planets. Then they found that Pluto actually has a lot of competitors. Once you get better telescopes, you can see that Pluto is just one of a large number of similar sized things that are in that very far outer orbit around the sun. And they've now decided to call it a dwarf planet. So they created a new category, and a planet that isn't got enough gravity to clear its orbit of other junk is now called a dwarf planet. But the argument wasn't over, because at the time I did this slide, I read how this mission to Pluto has taken close pictures of it, and they're really quite excited by the geological features, which they think, maybe we should call it a planet after all. But that means adding a different feature into the definition and having another major row and a major convention of all and a vote in the astronomical society of the world or whatever to form these categories. This is a lovely study that was done by Levitis, Lydekker, and Freund. And what they did was to see, well, let's take a group of experts who've been studying for God knows how many years, a particular concept. They took the concept of behavior. And so they approached members of 3 different professional societies for the study of behavior. And they got them to agree to take part in a little survey. First, they had to look at 13 different definitional statements, which they had to say whether they agreed with or not. They were allowed to say they couldn't decide. And then there were 20 different phenomena, which they had to decide whether they were examples of behavior. So you'll notice the first of these is like the prototype intention, the properties that go into the concept. And the second has to do with the extension, with the categorization of things as behavior or not. I'll just quickly show you the examples that they used. So the one that had the highest agreement is a definitional statement. A behavior is always in response to a stimulus or set of stimuli, but the stimulus can be either internal or external. Whereas the one they didn't like at all was behavior always involves movement. Here are the things that they had to categorize. The one that was definitely behavior for everyone was flocks of geese fly in V formations, or a spider builds a web, uncontroversial. Clearly not behavior, a horse becomes arthritic with age, or a beetle is swept away by a strong current. Poor beetle, but it wasn't the beetle's behavior. And in between, as you can see, there are a whole range of things which are more or less behavior. What Levitis did was, of course, to see whether people were contradicting themselves. And in fact, over half of the people in the study offered contradictory views. They would tend to say that this is a definition of behavior, but then they would accept something was behavior that didn't fit with that definition, or vice versa. And so it seems that they share an understanding of behavior, very deep understanding of behavior, but it's not in the form of a classically defined concept that they could agree on. And there are definitions of behavior if you look in different texts and theorists, but they don't have a common agreement. Levitis finally they came up with what they suggested was a new definition as a positive out of this study, rather than just poking fun at the scientists who have been studying something and they don't know what it is. I've said here that cognitive science also needs to be careful about understanding what a concept of concept is, because I think we're often in the similar situation of, I've spent the last nearly 50 years of my life studying concepts, and do I know what they are? Well, don't ask me at the end of the day anyway. So I want to then move on to the last part of the talk. Seem to have been, I know that I started a bit late because of Eugen's introduction. And I want to talk a little bit about genericity. So the idea of a prototype is that not every property that is in part of your concept, but perhaps many or most of the properties that belong to the concept are things which are generally true. They're not true necessarily or universally. So you say birds fly, you say tigers have stripes, you say ducks lay eggs, and these are true. They're considered acceptable true statements, but they're defeasible. They suffer contradictions, counterexamples. And one way to think of this is George Lakoff's idea that the concepts are idealizations, prototypes. That's from his amazing book, Women, Fire, and Dangerous Things, from 1987. So how do we know about, where do we find generic properties? Well, one simple way is, this is from my PhD in 1976, before many of you were born. I just asked people a whole bunch of questions about different categories, like what makes something a fruit rather than not a fruit? What would make something a typical fruit? If it was an atypical fruit, why would that be? What's it missing? Why might you say it's loosely speaking or technically speaking a fruit? And I also asked about metaphor, but that was not so fruitful. Here's the kinds of things that people produce. The ones at the top are the ones that most people produced. The ones at the bottom were less common. And you can see that they are generally true of furniture. It's attractive, it's found in the home, but it's not, none of them true of all furniture. And even if, birds, they all have beaks, but that's not enough to define a bird. Birds, I used a wrong example. Birds do have a clear definition, but fish don't, and lots of other creatures don't. So these intentions, these properties, vary in a number of interesting ways, and it's not just how frequently people associate them. It's also shown that they can vary in centrality or mutability. So you can say, how easy would it be for something to be furniture and have no legs? That doesn't seem difficult at all. How easy would it be for something to be a bird and have teeth? Well, just about imagine that. A bird that had no blood. Now we're getting into trouble. So there are different properties that are more or less deeply embedded into the schema, the causal schema of how the whole thing works. And you can show that those have produced behavioral effects in a number of different tasks. There's a very interesting paper by Prasada and Dillingham, which looked at different kinds of generics and suggested that you can have two different kinds of statement. Dogs have 4 legs, they argue, is principled because it actually is derived from the schema underlying dog. So you can say things like, it's in virtue of being a dog that a dog has 4 legs, or a normal dog has to have 4 legs. It's almost a sort of moral imperative that to be a dog, you ought to have 4 legs. Whereas cars having radios, it's very common. Not for a long time have I seen a car that didn't have a radio, but doesn't feel right to say it's because it's a car that it has a radio. It's just a fact. It's a statistical fact, but not a principled or conceptual fact. So I want to give you some examples about how this kind of generic prototype intentions lead to thinking without thinking. And I'm going to go through these 4 different examples, if you bear with me. the Linda problem, intransitivity in classes, non-logical forms of conjunction, and what I call the inverse conjunction fallacy. And I probably won't have time to get onto the generics at the end, but that won't matter. It's as I said, it's just a snapshot of a particular recent research area. I'm sure you know the Linda problem, but just to remind you, you're told a story about Linda. She was a radical in college. She ran the student magazine, etc., etc. And a few years down the way, we're asked to given a whole lot of statements about Linda. There was, I think, about 8 or 9 in the original experiment. One of them was that Linda is a bank teller, and the other is that Linda is a feminist bank teller. And you had to rank order these statements in terms of what was the most likely to be true. And just about everyone, and it's a very common intuition, which you probably share, is that it's more likely that she's a feminist bank teller than that she's a bank teller. But of course, being philosophers, you know that there's a question of entailment here, which is that if she is a feminist bank teller, that entails the statement that she is a bank teller. So it's not possible for the second one to be more true than the first one. Now, I won't go into it, there's been a host of research and arguments about what is going on here. Do they assume pragmatically that you mean a bank teller but not a feminist, and so on? But all I want to say is that the reason you're getting this strong impression is because you're judging the likelihood in terms of representativeness, which is what Tversky and Kahneman were arguing too. That you've got a prototype of a bank teller, you've got a prototype of a feminist. You can put them together just about and form a conceptual combination of the feminist bank teller. And then you take Linda and you say, well, if I compare similarity to these two prototypes, how good a reading am I get? And you're getting a much better reading from the feminist bank teller. And so you're not thinking extensionally at all, you're thinking intentionally in terms of matching of features, and that gives you the wrong answer. Now, the same actually happens with categorization. So often we think of generics as things about properties like birds fly, but we tend to think that birds are creatures or robins are birds as not suffering from this genericity. They're more kind of stable statements about the structure of semantic memory, which for heaven's sake, we need some kind of structure in life if we're going to be able to make sense of things. So if you remember Collins and Quillian, it's a classic in cognitive psychology. They had a default hierarchy with creature at the top, and then the animal kingdoms below that, and then particular types of animals below that. And you had is-a links going up. So a trout is a fish, is a creature, and so on. And an early study just after my PhD, I examined whether this was really the case. So take the example of furniture. If you ask people to list what things are furnitures, they will come up things like chairs and tables and chests. And if you look at images in Google for these, you'll find that they are all examples of furniture indeed. So I would say that these are all furniture. But you can also come up with examples of chairs, tables, shelves, lamps, and chests, which are not furniture. So a child's car seat, I would say, in fact, my participants agreed, is a kind of chair. A tennis table is a kind of table, but it's obviously not furniture. So you've got this problem, apparently, that when you say A is a kind of B, it does not logically correspond to saying if X is A, for all X, such that X is A, X is B. It is not underlined by a logical form of class inclusion. What is that underlying form? Well, it is just genericity, just like with the properties. It's to say that by and large, the similarity is big enough for this thing to be in that thing. And so the prototype of a chair is such that it shares a lot in common with the prototype of furniture. And if you take an atypical chair, like this one on the left, it no longer has enough in common with furniture. The reason the prototype features that make something a chair are different from the prototype features that make something furniture. And if the features of the subtype are not a superset of the features of the other type, then you're going to get intransitivity. This also applies in a lot of research that I did later on in the 1980s to conceptual combinations. So things like the relative clause, a sport that is a game, your logical form would appear to be all X such that X is a sport and X is a game, a conjunction. But when I did some studies just asking people to list a whole bunch of things, including these borderline cases, as to whether they were sports, whether they were games, and then whether they were sports which are games or games which are sports, you find that there are consistent systematic deviation from the logical interpretation. For example, chess is more likely to be called a sport that is a game than it is likely to be called a sport. And again, there are lots of arguments about just why this is happening, but it does seem to be easily demonstrated. It's very replicable, very robust effect. If you put a negation in, then you get effects like a horse is hardly ever called a vehicle, but if you ask, is it a vehicle that is not a machine, you get a whole bunch of people saying yes, which again breaks the basic class inclusion of a conjunct being a superset of the conjunctive set. You can get it with disjunctions. A mushroom, you ask people, is it a vegetable? Yeah, maybe 40% will say, oh, okay, but mushroom is a vegetable. You say, is it a fruit? Nobody wants to say it's a fruit. Ironic, because biologically it is a fruit, but nobody says it's a fruit, okay? Then you say, is it a fruit or a vegetable? Yes, 70, 80% is saying, yeah, it's a fruit or a vegetable, but it's not a vegetable and it's not a fruit. So these natural language connectives in regular speech and the way people understand the language, they appear to have this logical form. And thank goodness we do understand logical form and we can do logic. Otherwise, we would never have made it as a civilization. But in everyday colloquial speech, we don't pay much attention to it. So I'll talk about this one and then I'll come to a close. So this is a study, a set of studies I did with a wonderful young philosopher, Martin Jönsson, who's at Lund in Sweden. And he came and spent some time with me in London and was like the best postdoc I ever met. He was still doing his PhD, but he would have horrible colds that he would get in London. He had no immunity to London colds, but he would soldier on, and in a couple of months, he'd have done a couple of amazing experiments. So this is some studies where we looked at what happens when you add a modifier to a universally quantified statement. So all lambs are friendly compared to all dirty lambs are friendly. We got this idea from a study by Connolly, Gleitman, and Fodor, where they didn't have the universal quantification. And they showed that putting any kind of modifier in front of a statement tends to reduce the number of people who say that it's true or acceptable. So dirty lambs are friendly is considered less true than lambs are friendly. We were thinking, well, if you put a universal quantifier on, that shouldn't happen anymore. If you think that all dirty lambs are lambs, then if all lambs are friendly, it should entail that all dirty lambs are friendly. So it should not be possible to prefer the first statement to the second. If all surfers have backrests, that should apply to the uncomfortable ones as well. So all surfers have backrests should be more acceptable. More people should endorse it as true than all uncomfortable surfers have backrests. What happened was that every time, very strongly, people preferred the more general unmodified statement as being true. We tried it many different ways. I think we ran 5 experiments. We had the two side by side so that any kind of pragmatic effect would be ruled out. It was really, really difficult. One idea was, well, we know that all can be very vague. After all, we all use all the time to mean things that aren't all true. So there's a kind of hyperbole involved there. So we thought, oh, well, what we'll do is have every single dirty lamb is friendly, as opposed to every single lamb is friendly, or 100% of. What happened then? Well, you get exactly the same result in every case. No difference between any of these data. People prefer the unmodified to the modified. And it's as if they haven't even read the fact that you put every single in or 100% in. They just go for the meaning of the sentence and they think, dirty lambs don't sound friendly to me. Whereas lambs, oh yeah, but I don't think of lambs as dirty normally, so that's fine. I'm going to say lambs are friendly because usually they're clean and nice. And when they're dirty, don't want to know. They're probably not friendly. And this is the thinking without thinking that we do with these prototypes and so forth. So I've talked a long time, and I think I should probably call it a break there. So thank you very much for your attention. I'm happy to answer questions now, and I'll stop sharing my screen.
Well, thank you very much indeed, James, for this wonderful, comprehensive overview. I suggest that we now give people 2 minutes time to collect their thoughts and think of clever or other or any old questions, really. While in the meantime, we are going through a little meditation exercise in the shape of looking at some QR codes, which those members of the audience who are students at UEA are kindly requested to take a photo of with their phone. So, James, have you retransferred the?
No, I will now make you the host again.
Thank you very much.
Okay.
And you might as well stop the recording as well.
Oh, okay. Yes, I'll do that too.